Good day. Welcome to Chem 1151, and we're going to start off with Unit 1, an Introduction to Chemistry and the Sciences. This is the first video in Unit 1, and we're looking at chemistry's role. Basically, why on earth do we study chemistry? So let's look at an example, and if you've ever chopped wood or fell a tree before, this might sound familiar, and if you're like a lot of people, you probably haven't. So let me talk a little bit about chopping down a tree. So if you're going to chop down a tree and you're going to use an axe, now of course nowadays, a chainsaw is a whole lot easier, or even just a not chainsaw, a normal saw. But if you're going to go old school and you're going to use an axe, if you're going to fall down or fell a tree, so chop it down, you're going to grab yourself an axe. And axes usually have a slightly curved handle. They're about a medium weight, around about a 3-pound head, and those things are going to be sharp. You might not be able to shave with it, but then again, you might be able to shave with it. You want a good sharp axe. And when you swing and whack that tree, you are not going to take it down in one blow. You are not Paul Bunyan. At least I assume you're not Paul Bunyan. You might be, but I doubt it. So you're going to take a relatively small chunk of the tree out. Not go clean through. And so you're going to have to do it again and again and again and again and again and again. And after a surprisingly large amount of work, the tree eventually falls down. Hopefully you are not standing on the side where it goes kapoomp. Make sure you're not standing on the side that goes kapoom. Now, what you're somewhat more likely to do is to buy firewood. And if you have a bunch of logs that you've purchased, sometimes you get them pre-split, but if you don't have them pre-split, you're going to have to go split those yourself. So if you want to go splitting your logs, and once again you want to go old school, you don't want one of the hydraulic rams, it's a good workout. You get your log, you put it on, something to hold it nice and steady. It's not generally a good idea to put it on the ground. And you're going to grab your maul. Now mauls look like axes, but they got a couple of differences. One, their handles are usually straight. They're considerably heavier, around 7 pounds. This is basically because the maul is going down instead of sideways. You're working with gravity, not fighting it. And they're nowhere near sharp. They've still got an edge on them, don't get me wrong, but they're not going to be nearly as sharp as an axe. And with a maul on a normal log, within 1 or 2 strokes, you should be able to make that log into 2 half logs, or to half log into 2 quarters. It's going to go through it. And so you're going to be swinging through with a somewhat heavier but noticeably less sharp maul, going through several feet worth of log at once if you've got a good swing. Whereas the axe, you were going through inches if you were lucky with one swing. So why is cutting down the tree so much work and splitting the log, it's still a lot of work, but nowhere near as much? Well, you got a couple of things going. One, you got physics. You've got gravity, and you're working with it. When you're trying to chop down the tree, your swing is going horizontally, and you're just, gravity's not helping you. It's maybe hurting you a little bit. But what you also have got is a lot of chemistry going on. And if you zoom into your log, what you'll notice is that trees are made up of predominantly cellulose. Cellulose is this long, thin molecule, and it runs up and down the tree. Now, it's not the only thing on the tree by a long shot. The other thing that's important here is a molecule called lignin, which kind of connects your celluloses together. But when we look at the cellulose, it goes up and down the tree, and that's what we call the grain of the wood. And, it goes once again up and down the tree. When you are felling the tree, when you're cutting it down, you're going against the grain. You're trying to cut each grain apart. Whereas when you are splitting the log, you're trying to separate the grains apart. So you're, instead of trying to cut individual cellulose molecules, you're just trying to take them apart. What turns out, the forces holding the cellulose model together are around 100 times stronger than the forces holding 2 cellulose molecules to each other. So there's a lot less oomph trying to hold the tree together than it was trying to stop you from cutting down the tree. And you don't see this. You don't see why this takes place. You get the idea of what's going on with the grain, but the actual answer of what is the grain and why is it doing that, that comes from the chemistry. And that is going to be where, as chemists, we really come into play. Chemistry is going to be the study of chemicals. It's basically everything. We are studying how things are built and the interlocking building blocks of stuff. There's a German chemical company, one of the ancient dye companies we'll talk about a little bit later. They had an ad. This is BASF. They had an ad. We don't make the things you buy. We make the things you buy better. And that's really our philosophy in chemistry. We're not trying to quite often do the interesting, cool stuff. We're trying to figure out what the building blocks are and then facilitate the other disciplines. Help them do what they need to do. If we can understand how the building blocks work, what it's made out of, then we can predict what it will do, and we can hopefully change stuff to make it do what we want to do. We can create coatings that allow children's clothing to not catch fire. We can make brighter, colorful plastic blocks. Don't really have the ability to make them not hurt when you step on them, but that's more of a shape thing. But that said, though, we can help a lot of other disciplines by understanding what's going on the insides. So this wraps up part 1. Part 2, we're going to look a little bit at the origins of science and chemistry. So see you at part 2.